Hi, I'm David. So for this problem, we're given the function f of x is equal to e to the power of a negative x times the cosine of x. And they're asking us to graph this using our graphing utility as well as its damping factor. Now let's recall that the damping factor is the function that is multiplying the cosine of x, right? So that means the damping factor here in this example would be e to the power of negative x. So what does this mean? What does the damping factor do? What it does is that it essentially surrounds and affects what would normally be a cosine of x function. So let's see what that actually looks like. It might make a lot more sense, right? So let's use our graphing utility, go to y equals, and let's first just plot this function here. We have e to the power of negative x times cosine of x. And now we can go to a new line, go to y sub 2, and we'll type this one in. Now we'll type in the damping factor of e to the power of negative x. And we can always adjust the window as well. And when you press graph, you'll see both of the graphs being plotted. And you'll see that the cosine of x function is oscillating up and down close to what normally would have been e to the power of negative x. That this function, that this shape contains this shape over here. What this means essentially is that this function of e to the power of negative x times cosine of x exists in between the positive and negative version of this damping factor. In other words, this function of e to the power of negative x cosine x is greater than or equal to negative e to the power of negative x, and it is also less than or equal to positive e to the power of negative x, meaning wherever this exists, this cosine of x function is bouncing back and forth in between the positive and negative versions of this damping factor. That is the definition of what a damping factor does. Meanwhile, if you look at your graphing utility, you'll also see that the functions, that the e to the power of negative x cosine of x function touches the damping factor at y equals the positive and negative version plus or minus of e to the power of negative x, but only at points where x is equal to pi, meaning every 180 degrees or pi radians. So we can just say x is equal to n times pi, n representing a integer, meaning it could be 1 pi, 2 pi, 3 pi. Every 180 degrees, every pi radians, this function will touch this function, right? Every time it oscillates, every 180 degrees when it oscillates, it will touch this damping factor. Meanwhile, it will also intercept this damping factor at, let's see, we can use the second calc trace button, and we'll see that it has several intersections, right? And so it intersects at x equals pi over 2 plus n pi. What this means is that this function will intersect its damping factor starting at pi over 2 radians, in other words, 90 degrees, and for every 180 degrees after that, it will intersect again, or in other words, every pi radians, it will intersect this damping factor constantly into infinity. And that is how you solve this problem.